Good morning students. In this video we will discuss integration by parts. So continuation of integration. Already I made 7 conceptual videos. This is 8th one. So I am providing complete classroom teaching. Please note this point. So in this video we will discuss integration by parts. What is integration by parts? So if integral, listen carefully, f of x into g of x. If f of x, g of x are two functions, when their product is there, how to integrate these? This rule says that integration by parts, when there is a product of two functions of x, then its integration will be f of x into integral g of x into dx minus integral of d by dx. D by dx means dash, derivative. D by dx of f of x into integral g of x dx. For entire this product, again we have integral now, therefore into dx. Yes, this is the integration by parts rule. If product of two functions f and g is there, to integrate that product we will use this. This is known as integration by parts. What is this? This is integration by parts. See how this comes. I will take this carefully. I am taking this f of x into integral g of x dx. I took this. For this I will differentiate. Differentiating means d by dx, or you can write f dash x. Okay. Now we are performing differentiation. These are the two functions. In differentiation you should apply uv rule. U into v dash plus v into u dash. Okay, we will apply that. Say this is u, this is v. Firstly, u into v dash, carefully. U into v dash, derivative of this. These are the two functions here for which we are differentiating. U into v dash. What is dash of this? Dash means derivative. Already integral is there, no? Integral and differentiation, they are inverse process, therefore gets cancelled. We will have derivative of integral of g of x is gx. Next plus what I wrote, uv whole dash, u into v dash. Now v into u dash. What is v? V is integral g of x dx into u dash. U dash means d by dx of f of x. You can write dy by dx or dash into dx. Now I will arrange this as f of x into g of x. F of x into g of x is equal to, I wrote this. I will be writing this on left side. See Nana. So what is there already on the left side? On the left side we have f of x into integral g of x dx whole dash. That means derivative is there. This comes on the left side, it becomes minus dx into f dash of x, that is f dash of x into dx. You can write like this, no problem. Now to get this formula, I will integrate this. Integrating on both sides, of course with respect to x. If I integrate this, I will be getting integral f of x into g of x dx. Carefully, I am differentiating this for entire this product, entire this expression, for entire this bracket, dash is there. Dash means derivative. Dy by dx is there for entire this term. We are integrating, no? Integration and differentiation, they will be cancelled. We will have f of x into integral g of x dx minus, again we are integrating this, so one more integral. I will write this here. What is this? F dash x. F dash x, or you can write it as d by dx of f of x. What is there? Integral g of x dx is also there. This is already there. We are integrating, therefore for entire this you will get integral dx. That's all. This is nothing but this rule. So therefore integral f of x dx is equal to f of x plus integral g of x dx minus integral of d by dx of f of x integral g of x for entire product, again integral dx. This is known as integration by parts. So here f and g are two functions. Here f is known as first function, g is known as second function. Instead of writing f of x, g of x, simply you can take uv. Integral uv dx is equal to, simple. So what is this? First function u into integral v dx minus integral of d by dx of u into integral v dx for entire this, one more integral dx. Yes, this is to be remember. This is formula procedure to integrate product of two functions. This is known as integration by parts or integration of uv product. Here u is called first function. U is called first function and v is called second function. Yes, when two functions are given, which is to be taken as first function and which is to be taken as second function. So there is a rule. So second function, you should select a function as a second function whose integration number of times should be very simple. That should have integral, simple integral. Such function is selected or taken as second function. Remaining will be automatically first function. First function should be suitable for differentiation, whose derivative must give us simple integral. Once again, how to select these two functions? Second function, there are two functions, no? The function whose integral can be evaluated easily number of times. The function whose integral can be evaluated easily number of times, that should be taken as second function. The remaining one as first function. What about remaining function? That should be suitable for differentiation. That output derivative should be in the form of a simple integral. Yes. So some authors, when you have to select that first function, second function, they will take a phrase. Which phrase? Isolate. they take this phrase isolate. In this order they select the first function. This is to select the first function in order from left to right. This is the order of preference. I means inverse trigonometric functions. L means logarithmic functions. A means algebraic functions. T means trigonometric functions. E means exponential functions. Once again, I is for inverse functions, L is for logarithmic functions, A is for algebraic functions, T is for trigonometric functions, and lastly E is for exponential function. In this order from left to right, you are supposed to choose the first function. For example, if you have a function like this, what is that function? E power x into x square is there. So what is e power x? E power x is an exponential function. And what about x square? It is an algebraic function. So product of two functions. For that we need integral. You are supposed to apply, when two functions are there, you should apply integration by parts. If you want to apply integration by parts, we need to select the functions. First function, second function. What is the rule to find first function using this phrase? First preference is I. You see which functions are there, A and E. Which is coming first from left to right? Algebraic function is coming from first. It is coming first. So this should be first function. This should be what? First function U. Exponential remaining function will be automatically can be taken as V. Then you proceed by this rule. You will be getting integral. Now we will see one application. See, integral e power x into f of x plus f dash x into dx, of course. Its integral is e power x into f of x plus c. See, this one can be taken as a formula, of course, which is important formula. You are supposed to add this to the list. This should be added to the list. See. So how it is, what it is? Integral e power x into f of x plus f dash x. Here bracket is there. This one. Integral e power x into f of x plus f dash x. Its integral will be e power x into f of x plus c. See how it comes. I will take e power x into f of x and I will find its derivative. Yes. How to find the derivative? When two functions are there, product rule, UV rule should be applied. What the rule says? U into V dash. Dash means d by dx. Plus V into U dash. U dash is what? E power x. I have differentiated this. I can take e power x common. If I take e power x common, I will be having f of x plus f dash x into, not into, that's all. So we need the integral of this. This function has come here. Therefore, now integrating on both sides. Integrating on both sides. If you integrate on the left, otherwise I will write this first. We have to integrate this, no? Therefore, integral e power x into f of x plus f dash x into dx. When you are integrating, this is the symbol of integration. It has meaning whenever you write dx only. Right. We are integrating this. I have integrated on the right side. I should integrate on the left side. Left side, what is there? Derivative is there. Derivative and integral, they are inverse, no? They will be cancelled. So we will have only e power x plus f of x. Since we have performed integration, that arbitrary constant will be there. That's what this formula says. Integral e power x into f of x plus f dash x dx. What is its integral? E power x into f of x. Okay, we will see another similarly. There is another formula. What this formula says? Integral f of x plus x into f dash x. Most important. If this one is there, into dx, its integral will be x into f of x. X into f of x plus c. This is the integral. So this is another formula. Of course, very, very important one. So this is to be added to the list. This is also to be added to the list. It can be proved similarly. It can be proved similarly. See, if I take right side one, x into f of x, and we will differentiate this. If you differentiate this, there are two functions. You should apply uv. So u into v dash, dash means f dash x. Next v into u dash, x derivative 1 only. Now what we do for this product, we will integrate on both sides. Here also you should integrate. This integral and differentiation both will be cancelled. What will be there on the right side? Integral. What is there? F of x is there, and plus x into f dash x is also there. Whose integral is equal to, what is there on the left side? After cancelling integration and differentiation, we have only f of x. Since we have done integration, c should be there. That's what this formula. So in integration by parts, we have seen the rule. What is the rule? Generally, uv rule is remembered. Integral uv dx is equal to, u is first function, v is second function. Choosing first and second functions. Choosing second function is more important. The second function should be easily evaluated number of times. That means that integral should be evaluated simply number of times. That is second function v. Automatically the remaining function will be first function. Now we have seen the rule and two formulas. Both are absolutely important. You should add these two to the list. Next we will see another formula. There is one more. Listen, what is this? Integral e power ax into sine of bx plus c into dx. Integral of this product is e power ax divided by a square plus b square into a into sine of bx plus c minus b into cos of bx plus c. Since it is integral, there should be a integral constant, arbitrary constant. Generally we write c. In the problem, in the formula already c is there, no? I will take k, no problem. You can take any letter. This is another formula, Nana, which is very important. See, this is what left side integral is there, no? Therefore I will suppose I will denote this by I. What is I? I is integral e power ax into sine of bx plus c into dx. Now product of two functions is there. So I should use integration by parts. To use integration by parts, you should select first function and second function. See, using the phrase isolate. So what is this? E power ax is exponential function. This is what? Trigonometric function. Which one is coming first? Trigonometric function is coming first. Therefore this is first function, the remaining is second function. Yes. Now I will apply integration by parts for this. What the rule says, integration by parts, simply integral uv dx is equal to, where u is first function, v is second function. This rule says that u into integral v dx minus integral of d by dx of u first function integral v dx. For entire product, once again this integral. This is the rule. So listen carefully. What is this? This is u and this is v. Firstly we get u, no? Therefore sine of bx plus c into integral v dx. What is v? E power ax into dx minus integral of d by dx of u, that is d by dx of what is u? Sine of bx plus c is u, first function, into again integral v dx. For this product we have one more integral, no? Integral dx. Yes. We have applied integration by parts. Now let us simplify. See carefully. Here integral is there, no? First one is outside the integral. We have sine of bx plus c into integral e power ax. Ax is a linear function. You can apply a power x, no problem. What is the integral of a power x? E power x. E power x is e power x only. In place of x we have a linear factor whose derivative is a. Therefore divided by a comes. Next integral of, here d by dx of sine. What is the derivative of sine? Cos. We have applied sine x. In place of x, bx plus c is there, whose derivative is b. What is this? This is differentiation. Therefore b comes in the numerator. Then integral e power ax, already done. This will be e power ax by a into dx is there. Okay, now carefully. What is this? This is e power ax into sine of bx plus c by a is there. Next here, what are the constant? B is there in the numerator, a is there in the denominator. Again we have two functions. Which functions? Again we have this and this. So again two functions are there. We have started with two functions. After performing integration by parts, again we have two functions. Let us integrate one more time using same UV. Which function is first function? Trigonometric function is first function. Therefore, this is what? Cos of bx plus c into integral of this. I am writing directly. E power ax integral is this. Next, minus integral of d by dx of this. Cos integral is minus sine. Therefore, this becomes plus. And again, by differentiating this, we will get b. Integral e power ax is again e power ax by a only. Yes. So here in this integration by parts, we are integrating. Integration is done at partially somewhere. Here we are doing integral, here we are doing integral. For whenever you do integration, that integral should contain constant. So it is enough if you write the constant at the end of the integral. That's okay. See, once again I have performed integration by parts. So what we have now? We have e power ax by a into sine of bx plus c. Yes, if this b by a multiplies both. If I multiply this will be b by a square e power ax into cos of bx plus c. Then plus into minus minus. B into b is b square and a into a is a square. I have written the constants outside. What is there? Again we have, after writing the constants outside, again we have two functions here, sine and this. Listen carefully. We have started with the product of two functions. To find its integral, we have applied integration by parts. Two functions still are there. One more time I have applied UV, still two functions are there. In the beginning, sine and e power ax. In the second step, cos and e power x. Again changed to sine. If you integrate once again, this is same function, no? This function only, e power ax into sine of bx plus c. That means sine and cos will be repeating infinite number of times. That means here integration by parts is not giving final answer. For such problems only, there is another method, successive reduction. We will see in the next exercise that. Presently what we do, we have written this b and a outside, it becomes b square by a square. What we have now? Integral e power ax sine of bx plus c. E power ax sine of bx plus c is integral, which can be denoted by I, which is nothing but given integral I. That means we are reducting that. If you continue the process, it will not end. Sine e power x. In the next integration, you will get cos, again sine, again cos, again sine. It never ends. Therefore, reducted this. In the question, we have to find this integral which is denoted by I. That means I is to be found. So that I term is negative, no? I will write it on the left side. What is there here? Left side I is there. We are writing that on the left side. It is b square by a square into I. Now what is there? These two terms are there, no? So I will take e power x common. If I take e power x common, I have sine of bx plus c by a, and here b divided by a square, into cos of bx plus c. I have these two now. Okay, here what I do, I will take I common. If I take I common, 1 plus b square by a square. Here you see e power ax. E power ax. Here I will take again LCM. If I take LCM, a square is LCM. Here only a is there, no? Therefore I will get a into sine of bx plus c. Here already a square is there, no problem. We will get only this. So I got this. See, finally in this problem we have to find what? Integral e power ax into sine of bx plus c. That is denoted by I, no? So I is to be found. So here you see what is there on the left side, I into. Here if I take LCM, I will get a square plus b square divided by a square. This is equal to, on the right side what we have, e power ax, and this a square can be written here. And in the bracket a into sine of bx plus c minus b into cos of bx plus c. We have this. Again I can cut a square a square. We need this integral which I have denoted by I. That means I need only I. So if you want to find only I, you write this factor on the right side. That is e power ax divided by a square plus b square into, what is there, a into sine of bx plus c minus b into cos of bx plus c. So we have this. So finally what is this integral? So we will take this as a formula. Actually it belongs to integrations by successive reduction. What is I? I was this integral, no? So integral e power ax into sine of bx plus c into dx. This is I, which has come, whose integral is e power ax divided by a square plus b square into a into sine of bx plus c minus b into cos of bx plus c. So integration has done, integral has found, there will be a constant, no? Therefore c is there in the question, therefore I will take another constant k. So this can be taken as another formula which should be included to the list, added to the list. Yes, what is this? Integral e power ax into sine of bx plus c. Similarly, you can do this. Integral a power x into cos of bx plus c into dx. You perform this. Similarly, its answer will be same, e power ax by a square plus b square into, here a into cos comes first, cos of bx plus c, and this will be plus b into sine of bx plus c plus integral constant k. So this is also a formula. You please add these two to the list. Yes. So in the two formulae, e power exponential e power ax into sine cos is there. In some books, I said these are two formulae. I asked you to add to the list. Please add. This can be same similarly if a power x is there, e power x. If a power x is there, then also you can find its integral in the same way. So I am not including those in the list of formulas. My intention is to get minimum number of formulas so that those can be found using integration by parts in the same manner, same procedure. Yes. In today's class we have seen integration by parts. UV formula we have seen, and we have also seen 4 formulae. Now let us practice some problems. Please see. Question number 1. What is integral of e power x into x log x plus 1 divided by x? What is the integral of this? Let us see. What is the integral of this? See Nana, integral e power x. We have a formula, no? Which one? Integral e power x into f of x plus f dash x into dx. We have seen what is this. Its integral is simply e power x into f of x plus c. So I will use this. We have seen a formula this. Now what about this problem? Here e power x is there. You will get the same here, e power x into. Here x divides both. If you divide separately, if you divide first one, x gets cancelled. And if you divide 1, you will get 1 by x into dx. What is this? Clearly f of log of x. Log x is a function. We know whose derivative is 1 by x. That means this is f dash x. Therefore, this integral is exactly in the form e power x into f of x plus f dash x, whose integral is what? Just e power x into f of x. Using that, its integral will be e power x into f of x. What is f of x? Log x plus c. That's all. Next we will see another question. Question number 2. Integral e power x into x plus 1 divided by x plus 2 whole square into dx. We will see another. So whenever e power x is there, you try this. So to apply that, we need integral e power x. So what should be there? F of x plus f dash x. Here I made this simplification. What is there in the numerator? X plus 1, no? In the denominator x plus 2 is there. Therefore I will write the numerator as x plus 2 minus 1. What is actually x plus 1? I wrote this as x plus 2 minus 1. This denominator divides both. Okay, we will write in the next step into dx. So now this can be arranged as integral e power x into, divide separately, x plus 2 by x plus 2 whole square. What is it? It is 1 by x plus 2. This also divides 1, therefore 1 divided by x plus 2 whole square into dx. Now see, this is what it is of the form 1 by x, whose derivative is minus 1 by x square. What is x plus 2? Linear. For linear, what is its derivative? 1 only. So this is what This is exactly f of x and this is its derivative. So it is of the form integral e power x into f of x plus f dash x. 1 by x derivative is minus 1. If you want, you can make it plus, write minus here. 1 by x, its derivative is minus 1 by x square. Exactly e power x into f of x plus f dash x. Therefore, its answer is what? Simply e power x into f of x. F of x means this one. So into 1 by x plus 2 means you can write like this. Plus c. So this is the answer for second question. This is the answer of first question. Yes, we will see another one more. See, question number 3. Integral log x divided by 1 plus log x whole square into dx. What is integral of this? Here e power x is not there, no problem. I will go with substitution method. I will suppose log x is equal to t. What is the derivative of log x? 1 by x into dx is equal to dt. This implies dx is equal to, this x becomes coefficient of dt, that is x, if you write x on right side, it multiplies. Log x equal to t means what is x? X is e power t into dt. By taking this substitution, this question, this integral becomes, what is log x taken? T. What is there here? 1 plus log x, 1 plus t whole square into, what is dx now? It is e power t into dt. Whenever you get e power t, you try this. So integral e power t into, what is there remaining? T by 1 plus t square. What to do? So you add and subtract 1. This 1 plus t whole square divides both. Into dt is there. Yes, therefore this can be integral e power t into, dividing separately. First one will be 1 by t plus 1 or 1 plus t. And second one is what? Minus 1 by 1 plus t whole square into dt. Yes. What is this? Again it is 1 by x is f of x minus 1 by x square is f dash x. It is 1 plus t is linear, you can apply, and whose derivative is 1 only, nothing to multiply and divide. So it is e power x into f of x plus f dash x. Answer is just product of these two. That means e power t into 1 by 1 plus t. It will be like this. But in the question t has not given. So replace t by log x. If you write log x here, e power log x is what? Simply x. 1 plus t is what? Log x plus c. So this is the integral. This is the answer. We will see another question. What is this? Integral sine of log x plus cos of log x into dx. We are not sure to which one should be applied. Therefore, I will go with substitution. I will suppose log x is equal to t. Then we will have 1 by log x dx is equal to dt. This implies dx is equal to x into dt. What is x? X is e power t from the assumption. dt. Therefore, by taking this substitution, the given integral becomes, what is this sine of log x is t? This is cos of log x is t. And what is dx? It is e power t into dt. Therefore, this becomes now integral e power t into sin t plus cos t dt. Whenever e power t is there, see here sine is there, cos is there. What is sine? Sine is if you suppose sine is a function whose derivative is exactly plus cos x. So now this integral, it takes the form integral e power t into f of x plus f dash x. We know the formula for this, e power x into f of x, that is sin t plus c. Therefore, e power t, what is e power t? Log x equal to t. If you take what is e power t? E power log x. E power log x is nothing but x into sine of t. What is t? T is log x plus c. Yes, this is the answer, integral. Next we will see another question. See next question, question number 5. You suppose, what is 5? Integral of x plus sin x divided by 1 plus cos x into dx. Yes, what is the integral of this? Let us see. So here this is not that much clear. Let us simplify. X plus, I will write sin x as 2 sin x by 2 cos x by 2, and I will write 1 plus cos x as 2 cos square x by 2 into dx. Okay, now I will divide separately. What will be there? X by 2. Cos square is there in the denominator. It becomes secant square. Then plus. If I divide this separately, see carefully, 2 gets cancelled. 1 cos x by 2, cos x by 2 gets cancelled. I will have only sin x by 2 by cos x by 2. So now what is this? This is integral of tan x by 2 plus x into 1 by 2 into secant square x by 2 into dx, of course. See, it is of which form? We have seen a formula. Integral, what is that? F of x plus x into f dash x. Also seen this. Of course, important this one also. If integral f of x plus x into f of f dash x dx, what will be the integral of this? See the list. Today only we have seen this. Just x into f of x. Here if you suppose tan x by 2 as a function, tan derivative is secant square x by 2. In place of x we have x by 2, its derivative is 1 by 2. If this is f of x, this is what? F dash x. Therefore, it is taking the form integral f of x plus x into f dash x, whose integral is x into f of x. So x plus tan of x by 2 plus c. That's all. This is the integral of this. See another question. What is this? Integral log x. So in the differentiation, d by dx of log x is 1 by x. There we have taken d by dx of log x equal to 1 by x as a formula. In integration, so far we did not write integral log x. Now we will do this. Can be taken as a formula, of course. Yes, how to integrate this? I will suppose this as only log x is there, no? I will write this as 1 into log x. What is 1? 1 is algebraic function and log x is logarithmic function. Now I will apply integration by parts. To selection of first function, I use isolate phrase. Isolate. What is L? What is isolate phrase? Phrase isolate is this, no? Which functions are there? Algebraic function, logarithmic. Logarithmic function is coming first. Therefore, this is u and this is v. Product is there. I will use integration by parts. First u into integral v dx minus integral of d by dx of u. U means log x into integral v dx. First you should learn the formula perfectly. Yes. So this is equal to log x into what is integral 1 dx? It is x. Next integral of d by dx of log x is 1 by x. Integral 1 dx is x into dx is there. I can cut these two. Therefore x into log x minus what is there? Only 1 is there whose integral is x plus c. Therefore integral log x dx is, you can take x common here, x into log x minus 1 plus c, of course. So this is the integral of log x. Frequently it comes in the problems, therefore you can also take this as a formula. Yes, next question number, next number. Okay, what is there? Integral x into secant square. X is algebraic function, secant square trigonometric function. So which one is coming first? Algebraic and trigonometric. Here are the two. A is coming first, therefore I should suppose this is first function and this is second function. Always second function should contain, the second function should be such that should be evaluated easily. What is it? Integral. That integral should be evaluated simply number of times. Okay. See now according to this, using this phrase, I decided this is u, this is v. So now we will integrate. First u into integral v dx, secant square x dx. Then minus integral of d by dx of u. U means first function. Integral v dx. What is v? Secant square x dx into dx. Yes. Now x into integral secant square x is tan x. That should a second function should always have simple integral. Next integral d by dx of x is 1. Integral secant square x is tan x into dx. Yes, therefore it is x into tan x minus integral tan x. We have integral tan x. See the list. What is it? It is log of mod sec x plus c. Yes, this is the integral. Next problem. Integral x into tan inverse x into dx. Again product is there, no? We will use integration by parts. Here x is algebraic function, this is inverse. So inverse comes first. Therefore this is u and this is v. And proceed. So first u into, u means tan inverse of x, into v dx, that is x into dx. minus integral of d by dx of u means tan inverse x, into integral v dx. For entire this we have one more integral, no, I should write dx. Very simple. What is integral x? X means x power 1. X power n use x power n plus 1 by n plus 1. That will be x square by 2 into tan inverse of x minus integral of, what is d by dx of tan inverse x? It is 1 by 1 plus x square. What is integral x? It is x square by 2. I will write 2 here into dx. Yes. So therefore it is x square by 2 into tan inverse of x minus 1 by 2 into integral of. To find the integral of this u by v, there is no u by v here. In the denominator 1 plus x square is there, no, therefore I will add and subtract 1. This denominator divides both. So this is 1 plus x square, this is also 1 plus x square into dx. Yes. Now this is x square by 2 into tan inverse of x minus 1 by 2 into integral. These two gets cancelled. We will have 1 and here 1 by 1 plus x square. Now both are standard integrands. They have integrals directly. X square by 2. And this is tan inverse of x minus 1 by 2 into, what is integral 1 with respect to x? It is x minus 1 by integral 1 by 1 plus x square is tan inverse of x. That's all. Plus c. Answer can be simplified like this. Here tan inverse x, we have tan inverse x. Okay, we will write one more step. What is this? X square by 2 into tan inverse x. Then we have minus x by 2, minus into minus plus, what is there? Tan inverse of x by 2. Yes, plus c is there. These three, they contain 2 in the denominator. I can take 2 common, 1 by 2 common. Tan inverse x, x square tan inverse x, tan inverse x. If I take tan inverse x common, x square plus 1 into tan inverse x, and here I have x. Yes, plus c. This is the answer. So this is integration by parts. When product is there, you should think of this. You should selection of a function, first function, second function is important. How to select? You always see the second function. The second function should be very simple to integrate. Number of times, of course. The other function should be suitable for differentiation. So we have seen the rule integral uv. You please learn that formula perfectly. Then we have also seen 4 formulae. E power x into f of x plus f dash x, and integral f of x plus x into f dash x, and 2 more. Integral e power ax into sine of bx plus c, integral e power ax into cos of bx plus c. So they write some more formulas. They are not required. These are enough. In place of e power ax, if a power x is there, nothing. You proceed as seen here. So these are the some concepts of integration by parts. Now one more concept is left, which is integration by successive reduction. So those who are watching my videos, this is my 8th video on integration, indefinite integration. So in these videos, what is the title of the videos? Concepts of indefinite integration. I am 100% going according to concepts only, no shortcuts. Only concept is very important. I believe that only concept is important, study in order is important. That's what I am doing this. Once we complete the total concepts, there comes one more video, integration by successive reduction. After that we will be discussing, we will be making videos on objective. There we will see all the shortcuts, verifications, etc. Okay, thank you.